Good evening. My name is Cynthia Cofield. I'm a graduate certificate student at East Carolina University. I'm doing a presentation this evening on solutions to cloud security issues and some future trends. My professor is Dr. Philip J. Lunsford. And again, my presentation will be on cloud security issues and future trends. Okay, topics of topics of discussion this evening will be written security policies plan, multi factor authentication, access to data, appropriate cloud model for business, such as software as a service, platform as a service, and infrastructure as a service, encryption of backups, regulatory compliance, a formal change control process, secure data destruction, and encryption scheme design and test. Other topics will be the top 10 security trends for 2019 and beyond. Then there will be a conclusion and references and citations. Okay, starting with solutions to cloud security issues. Number one, I think, would be having a written security policy plan, which is a set of criteria for the provision of security services. This will define the constraints and activities of a data processing facility in order to maintain a condition of secure data. That definition comes from our textbook. I did include a link for some examples of this and a template, an actual template of a sample data protection policy. Other solutions to cloud security would be multi factor authentication, sometimes referred to as two factor authentication or 2FA. This is a security enhancement that allows you to present two pieces of evidence of your credentials when you're logging into your account. Your credentials will fall into two, excuse me, any of these three categories. Something you know, like a password or a PIN, something you have, like a smart card, or something you are, like your fingerprint. Your credentials must come from two different categories to enhance security. So if you enter something like two passwords, that would not be considered multi factor. As an example of MFA, so say you swipe your bank card at the ATM and then you entered your PIN. That's two factor authentication. Or if you logged into a website that sent you a numeric code to your phone, which you then enter to gain access, that is two factor authentication. Another solution would be access to your data, aka data access. And the definition of data access in this instance refers to the user's ability to access or retrieve data stored within a database or some other repository like a cloud, or excuse me, like the cloud. Um, users may have data access, excuse me, users who have data access can store, retrieve, or move and manipulate the stored data. And it can be stored on a wide range of hard drives, external devices, or in the cloud. And there are three cloud service models that I'm going to be discussing. One is software as a service, one is platform as a service, and the other is infrastructure as a service. And all these were taken from our textbook. Software as a service provides services to customers in the form of software, specifically application software running on running on and accessible in the cloud. SaaS enables the customer to use the cloud provider's applications running on the provider's cloud infrastructure. Now, these applications are available from various client devices through a simple interface such as a web browser. This way, the client does not have to purchase desktop and server licenses for software products that they use. Example of SaaS would be Google Apps, Salesforce.com, NetSuite, Lotus, Web Filings, Zoho, Yahoo Mail, and Hotmail. Platform as a service provides service to the customers in the form of a platform on which the customer's applications can run. Platform as a service enables the customer to deploy on the cloud infrastructure the customer created or acquired applications. Platform as a service provides useful software building blocks such as programming language tools, runtime environments, and other deployment type tools. Effectively, PaaS allows the customer to pay for needed computing resources only as needed and only for as long as needed. Examples of PaaS would be the Google App Engine, Force.com, Windows Azure, Longjump, Rollbase, Amazon Elastic Beanstalk, and VMware Cloud Foundry. And there are other examples. These are just a few. Infrastructure as a service provides the customer with access to the resources of the underlying cloud infrastructure. The cloud service user does not manage or control operating systems, deployed applications, and has only limited control of select networking components, for example, host firewalls. Um, Infrastructure as a service provides virtual machines and other virtualized hardware and operating systems. Infrastructure as a service offers the customer processing, storage, networks, and other fundamental computing resources so that the customer can deploy and run arbitrary software, which would include operating systems and applications. Infrastructure as a service also enables customers to combine basic computing service such as number crunching and data storage. Examples of infrastructure as a service would be the Amazon EC2, Rackspace, VMware, Joyent, and Google Cloud Storage. Encryption of backups. And this information was taken again from our textbook. One of the principal security requirements of a computer system is the protection of the stored data or data at rest, and also data in transit. Now, backup is the process of making copies of data at regular intervals, which allows recovery of lost or corrupted data over a relatively short period of time. Encryption is a, a service that can be provided for data at rest in the cloud, or email traffic, or client specific network management information, and identity information. Encryption services provided by the cloud service provider may involve a range of issues, including key management, how to implement VPN services in the cloud, application encryption, and data content access. Another solution to cloud security issues would be regulatory compliance. And here are just 4 tips for keeping tabs on compliance in the cloud. Number 1, be aware of new challenges in the cloud that may add to your IT workload. Track the fast changing standards landscape. 3, take care of the service level agreement. 4, make security a priority. Okay. Now, formal change control process or change management. Here are 6 reasons why your cloud strategy should or must include a plan for change. The speed of delivery. You can meet the constantly changing business demands of getting new services to the market faster. You're delivering services versus delivering products. When you're delivering a service, development is never done as long as that service is being consumed by customers, unlike delivering products. Vertical versus horizontal architectures. Vertical architectures are typically made up of 2 or 3 tiers: web, app, and database. Architecting in the cloud means building software that is agnostic of any hardware and can automatically recover it as computer nodes go offline and new nodes come online. This is often called immutable infrastructure. You have control versus agility. And when you have multiple application teams deploying multiple times every month, this doesn't usually work and it's not scalable. You're choosing between, having control. You have more control with, say, like in a desktop environment with a data center, um, than you would over a cloud infrastructure. However, the cloud infrastructure would be much more agile, much more scalable. You cannot hire enough people to manually review the number of deployments that happen in a mature cloud environment. Data center tools versus cloud tools. Um, you have to look at if enterprises must reevaluate their tool choices as they move to the cloud. You want to pick the best tool for the job, not the tool that everyone is comfortable with. And also, when moving to the cloud, um, if a person is responsible for managing disk arrays and the company decides to move some or all of their storage to the cloud, then this person's role drastically changes. This may require retraining, or a different person may be needed to fill the role altogether. And a little footnote: a request for a change is a formal request for the implementation of a change submitted to the change management team or department. Secure data destruction is another element of having a secure cloud. Data destruction is typically the process of destroying data stored on tapes, hard disks, and other forms of electronic media so that it is completely unreadable and cannot be accessed or used for unauthorized purposes. Now, for the traditional type physical storage solutions, such as the tape, disk, and paper, there are already many well documented standards and procedures available. No, no, not really a need to go over those. Some of the sanitation standards go as far as removing the data beyond the recovery capabilities of your advanced forensic tools. Some solutions to data destruction in the cloud would be like data sanitization. The cloud provider sanitization services have few options. One reference material that I found was the DoD 5220 22M, which is the National Security Program Operating Manual. Or if you look at the NIST 800-88, which include guidelines for media sanitization. Um, Encryption is the use of storage. Excuse me. Encryption uses storage data at rest, encryption within the cloud environment. That doesn't even make sense. Encryption is used to ensure that if the media is not properly sanitized after leaving the service, then the old data is unreadable for any other party without the destroyed key. A hybrid solution might be feasible for For some, these servers and services are hosted locally, and some are located with a cloud service provider. This creates an opportunity to move the less sensitive data to the cloud and then leave the data requiring strict data sanitization policies stored locally. Also, isolation and virtual private cloud. This gives a customer more access to their isolated, dedicated network and hardware within the cloud. Say, for example, Amazon not only offers dedicated instances, but they can also provide dedicated hosts within their virtual private cloud. And lastly, data sanitization should be part of a comprehensive best practice security policy. Encryption scheme design and test. The definition for data encryption, it means that it's translating data into another form or code so that only the people with the access to the secret key, formerly called a decryption key, or a password, can read it. Encrypted data is commonly referred to as ciphertext, while unencrypted data is called plain text. Encryption is applied to data stored in the cloud. It doesn't help destroy the data. However, when the data is encrypted, even if someone accesses the residual remnants of the previous storage locations, the data should still be unreadable. Companies using encryption do not need to worry about the service provider destruction practices, and this approach can be helpful if private cloud environments as well, with computing resources expanding and becoming more dynamic. Encryption also solves other data access concerns, preventing unauthorized sources from reading and using cloud data. Always remember, no system is perfect. Stuff happens. Now going into the top 10 cloud security trends for 2019 and beyond. This is just a short list of the security trends that most users should be aware of for 2019. Trend 1 is access management. Trend 2 is data security. Trend 3 is infrastructure security. Trend 4, microservices security. Trend 5, threat management. Trend 6, vulnerability management. Trend 7, security software development. Secure SDLC. Trend 8, logging and auditing. Trend 9, incident response. And trend 10, compliance. And there is also a link there to download the ebook to get a comprehensive perspective on how these trends can address each area for, strong cloud security. And that is all I have. My conclusion, my advice would be hope for the best, but be diligent, be prepared, and be ready for the worst. And the next couple of slides are just my references and citations that I used in the presentation. That's all. Have a great evening.